load is only resistance and the source is impedance, then the value of resistance for the maximum power transfer is the mode of the source impedance. Is it okay? I hope these 4 points are very clear to you. This is all about the maximum power theorem. And you know the maximum, suppose if you want to get the value of R load resistance, you have to know first about the Thevenin theorem. So as I told you earlier that Thevenin theorem is the most important one, because we are using the application of Thevenin theorem in MPT also, maximum power theorem. And in the exam also, we apply, basically we apply the Thevenin theorem only, because sometimes they'll ask the bridge questions. In the bridge questions, we can apply easily the Thevenin theorem and we can get the value of equivalent resistance in the circuit. We can get the current in particular branch of the circuit. Okay. So let's start today with reciprocity theorem. Here we go. But before proceed, see this. Last time I gave you homework. I hope you people are doing that one also. For this particular one, the value of resistance is 25 ohm. If you solve this, you will get the value 25 ohm, and the VTH across this terminal A and B is nothing but your 28 volt. Is it okay? And if you will calculate the maximum power, that power will be 7.84 watt. Is it okay? Come to this question now. For this question, the equivalent resistance across A and B is, I can say RAB is nothing but 8 kilo ohm, and the power, maximum power is nothing but 1.152. Is it okay? So if you didn't solve this, please try once. It's very important, and gate level exam, this is the gate level problem. In the gate examination, they ask this type of problem only. Okay. Come to the reciprocity theorem. What reciprocity theorem says? The reciprocity theorem is applicable only to single source network. Please try to understand. We can apply the reciprocity theorem in single source circuits only if the circuit contains single independent source or independent current source or voltage source, whatever it is, then only we can apply the reciprocity theorem. And what the reciprocity theorem says? The current I in any branch of network due to a single voltage source. See, this is the circuit, suppose. According to the statement, the current in any branch of the circuit due to energy source. The current I in any branch of the network due to single voltage source E anywhere else in the network. This E may be here, anywhere. The network will equal the current. The network will equal the current through the branch in which the source was originally located if the source is placed in the branch in which the current I was originally measured. See what he is saying. Take a circuit. If in that circuit, in a particular branch, if the current is I due to E. Now interchange the position of these two. Okay, initially wherever we have I, we'll put E there, and keeping this in mind that the direction should not change, means in this branch current is coming like this. Yeah, current is flowing in like this. So if you are applying battery over here, the direction of the current should be like this only. That's why I am applying this battery or independent source, positive polarity downside. So the current will be like this. Okay. And in this branch where the source was initially placed, I replaced that by the current. And the direction of current is like this. Is it okay? So if we do like this, there is no change in the circuit. There is no change in the circuit. In Another way I can say the statement is, see, this is the response, right? The I is the response due to this. So according to the reciprocity theorem, the response and excitation ratio is constant. Response to excitation constant, excitation ratio is constant, or I can say the output and input ratio is constant. Okay, this is nothing but the reciprocity theorem. We'll see in a linear, passive and bilateral network, the ratio of response to excitation, see here, response means your I, excitation, your independent source E is constant, even though the source is interchanged from input terminal to output. Okay, it will be constant no matter you are changing or interchanging them, right? The theorem requires that the polarity of the voltage source have the same correspondence with the direction of the branch current in each position. Means if in that particular branch where the response I is given and the direction of the current is like this, when in this particular branch instead of I will apply the battery or excitation, the polarity of the excitation will keep like this, so the current value will be intact, I. Are you getting? Initially the I is like this, so we'll apply the battery or replace the battery in the branch like this. We can't apply the battery like this, remember, because if the condition is like this, the current direction will be opposite. So this point we have to keep in mind, okay? Now come to the presence of dependent sources makes the network active. Hence, the reciprocity theorem is not applicable. So friends, remember, the reciprocity theorem is not applicable while we are having dependent source in the circuit. If we are having dependent sources in the circuit, we can't apply the reciprocity theorem. Why? Because reciprocity theorem is only applicable for the passive network. Passive network. If we are having dependent source, it makes the circuit active. Is it okay for you? Okay. Come to the problems now. Determine the current I, here is the I, by reciprocity theorem for both the circuit. For both the circuit, we have to determine the current I. Is it okay? So, friends, the reciprocity theorem says I can replace these two terms. Isn't it? I can replace these two terms. So, I'll apply the reciprocity theorem because the people are saying like this. So, for this circuit, I'll rewrite. Here I'll apply the independent source and the polarity of independent source should be like this. So, the current direction will not intact. Okay. We are keeping the polarity like this, so current will be intact. Okay. Now, come to this. This is 4K. Okay, fine. This is 4K. This one is 8K and this one is 4K. Perfectly fine. Here, I'll apply or I'll replace this by current source. And what is the current source or current direction? Current is I and direction of current should be according to this. This is our I. Is it okay? Now, can we calculate this? Can we calculate this I? See friends, we'll calculate this. How? Wait a minute. So, to calculate this current, see, what I can do is, I'll assume the voltage V1 occurs here and V2 over here. Okay, and can I apply here the nodal analysis? This one I'll take ground. Okay, here the voltage is minus 10 volt. Okay, so friends, I'll apply the nodal analysis at V1 first. Okay, so at V1, if you'll apply the nodal analysis, here I'm writing for you V1 plus 10 divided by 4K plus V1 minus 0 divided by 8K, and this is the incoming current I equal to 0. Is it okay? This is equation 1. The equation 2 is V2 upon 4K plus V2 by 4K again, and this is the outgoing current equal to 0. Is it okay to you? Now friends, see one thing here. We are having two equations, and in these two equations we are having three unknowns, V1, V2 and I. What we need? We need I. So we have to remove V1 or V2, or we have to make two equations only. See, actually we are having only two equations, and if we will be having two variables, then only we can solve for the variables, right? So here the condition is given, V1 and V2 both are same, right? V1 and V2 both are same. Why? Because they are connected by a short path, V1 and V2. There is no any element in between them. Okay, that's why I can say V1 and V2 both are same. So V1 and V2, replace V2 by V1 only. Replace this V2 by V1 in entire equation. Now you can solve this equation. So you will get the current. Current is nothing but 10 by 28 milli. Like this you will get. Okay, please solve it. And this is homework for you. Okay, I think you will do it. This is the calculation part only. You understand the concept, what we have to do, how to remove one variable, how to make these two equations in double variable, two variables form. Two equations, two variable, we can easily solve. We can find out the value of I. Okay, this is all about the reciprocity theorem. What reciprocity says, again I am telling you, we can interchange the response and excitation. We can interchange. The circuit will not change, the circuit parameter will not change, and the response to excitation ratio is constant. In other words, I can say the reciprocity theorem is. Okay, come to the next one now, substitution theorem. It's very easy, substitution theorem, nothing. See what it says. It says, if the voltage across and the current through any branch of a DC bilateral network are known, this branch can be replaced by any combination of elements that will maintain the same voltage across the current through the same chosen branch. See, what is the substitution theorem? The theorem says, if we are having circuit like this, or okay, this is R1, R2, here the value is given at ohm, and across this the voltage source suppose known, and that is 5 volt. Substitution theorem says we can replace any branch in the circuit if the output will not change or the circuit will not affect. See, actually we have resistance 8 ohm. Across this 8 ohm we are having 5 volt. So can I replace this entire element by only single current source by the relation V equal to Ri? What is the V? What is the V? We have 5. What is the R? 8. What is the I? I is nothing but 5 by 8. So 5 by 8. So I can replace this branch by 5 by 8 current source, and the direction of current will be this side. Then only the drop will be like this. So this circuit I can substitute R1 here 5 by 8 ampere, and the remaining circuit is as it is. This is the simple circuit. So substitution theorem says we can replace if the voltage across and the current through any branch of a DC bilateral network are known, this branch can be replaced by any combination of elements that will maintain the same voltage across the current through the chosen branch. Okay, are you getting it? See here, it's given 12 volt independent source, voltage source. Incoming current is 3 ampere. So what is the power over here? 12 into 3, 12 into 3. It means this branch is consuming or giving the consuming because current is incoming. Okay, 36 watt power. So I replace this by this. See, 12. The current is 3 ampere here, current source, and the voltage across current source is 12 ampere. Here the power is 36 volt. Is there any change in the circuit parameter? No, not at all. Or I can replace this branch like this also. Here I am taking 6 volt battery. Okay, fine. Here I am taking 2 ohm resistance. In that 2 ohm resistance, the current is 3. So the remaining 12 volt I am getting by dropped voltage here. 6 voltage is dropped. So in the entire circuit, the voltage is 12 volt, 6 this and 6 this, total is 12, and the current is 3. Circuit parameter is not going to change by the substitution theorem. Are you getting? Simply substitution is saying if in your pocket, if you are having 500 note, where is the cursor? If you are having 500 note in your wallet, you can replace 500 note by 500 rupee note. Will there any change in the amount, in the money you have? No. This is the substitution theorem. Is it okay for you? Very good. So here we are having 4 combinations to replace any branch in the circuit. This is the substitution theorem. Okay. Rarely used in the network solving. Okay. So don't bother about it. Now Milliman's theorem. Rare used. Okay. So Milliman's theorem, what Milliman's theorem says actually, if we are having the circuit, complicated circuit like this, that complicated circuit we can replace by single circuit like this. But the condition is here, this is not like a Thevenin theorem. Here the condition is, if like branch like this, this is single branch having one voltage source and one resistance element. Like this, so many branches are connected together like this, parallelly, like this, so on. The combination should be like this only. Resistance connected in series with battery or independent source like this. If n number of branches are connected, we can replace them by a single source. In that single source circuit, the R equivalent will be given and the E equivalent will be given. Okay. It's like a Thevenin theorem, but there is a difference between this and that. Here the format is fixed. This type of format. If parallel branches are connected, here they are saying any number of parallel voltage sources can be reduced by a single voltage source like this, where the equivalent value of E equivalent is nothing but like this: E by R1, E by R2, E by R3 with a polarity sign. Okay, divide by 1 by R1, 1 by R2, 1 by RT, and like this. And R equivalent is like this. It's rarely used. Okay, so just know about what is the Milliman's theorem only. If this type of circuit you will be having in the circuit, you will not apply this formula. It's extra headache to remember this formula. Simply you will apply here nodal analysis. If you'll apply nodal analysis, this equation is nothing but the nodal equation. You'll get this equation only. Who will going to remember this? Simply we have to apply in the circuit, any circuit, KCL means nodal analysis and KVL. Okay. So this is all about the Milliman's theorem. Now I'm not going to do this circuit because direct formula is given, and this is not the important part of the circuit or circuit theorem, so I'm not going to do it, but I'm leaving it for you. This is homework to you. Okay, do once, you'll get the idea about Milliman's theorem, what it's saying. Okay, here we can replace this entire circuit up to here, 1, 2, 3, right? And R1, R2, R3 is given. Simply, okay, I'll do it for you. Equivalent is nothing but E1 by R1. What is E1? 10. R1 5. Now minus I'll take because minus polarity is given. 16 divided by 4 plus polarity is given. 8 divided by 2 divided by 1 by R1, 1 by 5 plus 1 by 4 plus 1 by 2. Here the positive sign will be there only. Let me check once. Yes, here only all are positive, the heading one. Now you can solve it. Okay, fine. Now come to the these all are dependent on using superposition theorem. Okay, now here we have finished all circuit theorems. We discussed about SPT first, then Thevenin theorem, Norton's theorem, maximum power theorem, substitution theorem, reciprocity theorem, and Milliman's theorem. These are the 5 or 6 types of circuit theorems we are having. Out of these 5 or 6 theorems, the most important theorems are Thevenin theorem and maximum power theorem. These two are the very, very important. Okay, as per the GATE exam is concerned. Now we'll start the problems. Okay, we'll see some high level problems and we'll take some GATE level problems also. So again, if you'll be having any doubts in the circuit theorem, I'll resolve all your doubts here in the problem section. Okay friends, so we'll take this circuit first. On a phrase page I'll take this. Okay, fine. Now the problem says we are having the circuit like here it is 24 and connected with 15 and again connected with 10 ohm. Here it is 24, this one is 42 and this is the positive one, this side. So friends, they are saying that find out the current over here in the 24 volt energy source, right? So see, this is a very easy circuit, right? This is array. Wait a minute. This one is also easy problem, but the circuit is given like this, so don't confuse yourself. Okay, first simplify the circuit. This 42 voltage source is given. This is nothing but with respect to ground. So I can say like this thing is given like this. This is the ground for all. For all grounded part we can connect together. Okay. I can resolve this two part. They are connected in parallel. So 15 into 10. 15 into 10 divided by summation 25. 5, 3 and 5, 5. 5 2 ja. So this is nothing but 6. I can replace this branch by 6 ohm resistance first. Nothing. I'm just simplifying the circuit. Okay. So don't worry about this. I'm just simplifying the circuit. Here I'll take 6 ohm. Now he is saying that find out the current in 24 volt an independent source by SPT. By SPT. The first step, I'll keep 42 volt and turn off 24 volt. Is it okay? How I'll do this? This is 42 in the circuit, 18 connected with 9. Here this is short and this is nothing but 6. Is it okay? Now my task is to find out this current. I'm giving it I1 because the first source is active and the second source is deactive or turned off. Now what is this current actually? So to calculate this current, I should be having this current first. Right? So how I'll calculate this current? I'm having 42 volt V equal to Ri. Can I apply? I should know the R equivalent of this circuit. So yes, I can find out the R equivalent. 9 and 6, they are connected in parallel. Okay, I'm just calculating the I. That's why this part is I'm removing. Okay, because I'm calculating the R equivalent. 9 and 6, they are connected in parallel combination. So resultant is 3. This 3 and this 18. This 3 and this 18 are connected in series. So the final combination, the equivalent circuit is like 42. Here it is 21. So the current in the circuit will be, please tell me, the current in the circuit will be 2 ampere. Is it okay? So once you get the 2 ampere, now this 2 ampere is coming here. Now I need the current in this current division rule. The I6 is nothing but the main current, that is 2, opposite branch resistance, that is 9, the summation 9 and 6, 15. 15. Is it okay? So this is 18 by 15. So you calculated I1. I1 is nothing but 18 by 15. Is it okay? Good. Now I1 you calculated 18 by 15 ampere. Now we'll short the 42 volt source, that is short circuited now, and your previous one original circuit is, this is 18, this is 9, short circuited. Over here we are having battery like this 24. You have to calculate this current. I'm giving the name I2, and here this is 6. This is 6. Is it okay? I have to calculate I2. This is nothing but 24. Again, I need the resultant to calculate I2 first. Now see, 18 and 9, they are connected in parallel. This is the starting point, this is the ending point. They are connected in parallel combination. So 18 into 9 divided by 18 plus 9, that is 27. So 9 3 ja and 6. So this combination is 6. This combination is 6. This combination is also 6. So 6 and 6, they are in series. So finally we are having 12. So finally your circuit is this 24 volt. This is I2. Here I am having 12 ohm connected like this. So what is the value of IT? IT is nothing but 24 divided by 12, that is 2 ampere. So I2 I need. Yes, I get the value of I2, that is 2 ampere. Now I need the final current. So algebraic sum of 2 ampere plus 18 by 15. Is it okay? This is nothing but our answer. The direction of both current are same. That's why we are adding this. Is it okay? This is all about the SPT. But in the examination, suppose you are getting this problem. So they will not say that using superposition theorem and something. They will simply ask find out the current over here. So in that case, in your exam, if you will get this, I'm simplifying this circuit. This is nothing but 18. This is 42. This is 42. So what you will do? Just do by nodal analysis. Hardly in 1.5 minutes we'll get it. Okay. Now using the superposition theorem, find the voltage VR3. Where is the VR3? Here. Here is the VR3. By superposition theorem, you can easily find out. This is the homework for you. This is the very easy actually. And remember, while solving at your home, please apply the superposition theorem. If you will use the superposition theorem concept, so you will be thorough with the problem. Okay. Now, come to the next one, and that is, in this question, using the superposition theorem, determine the current through the 56 ohm resistor. Where is the 56 ohm resistor? Here it is. They already mentioned the direction of current also. Okay. So in your final calculation and your final answer, the I direction should be referenced because it's already given. Is it okay? What I mean is, if by calculating the current, your current is coming like this, 55 amperes suppose. But you have to give your answer according to the given direction. It means the current direction you got is opposite to what is given. So your answer will be minus 5 ampere. Is it okay? Because here it's mandatory to give the answer in the form of given direction only. Is it right? Come to the question. The question is a bit easy. He is saying that by the superposition theorem we have to find the I. How many sources are here given? Only 2. 24, and the circuit is looking like open. This is not open circuit. This is closed circuit. Okay. All points are grounded, and this 24 is given with respect to ground only. So I can, draw the circuit like this. The circuit is given like this. All points are ground points. We can join. Okay, like this. Now this become very easy problem. Again, this problem is for you. You can do it easily. Come to the fourth one. Find the current in R1. Where is the R1? Here is the R1. Current direction. Okay, no problem. I1 we have to find. We have to find the R1. Okay. How many independent sources are given in the circuit? 3. 1, 2, 3. So one by one we'll choose, and then we'll find 3 individual currents. I1, I2 and I3. At the final stage, we'll take algebraic summation of these 3 currents. Means we'll keep the direction in mind while calculating this part. Is it okay for you? Come to the next one. The problem 5 says, for the linear circuit shown in figure, this circuit is given is the linear circuit. Use linearity to complete the following table. We have to use the linearity property. Linearity property says, if I can say, see, V0 is the output. This is K times of Vs. Is it okay? This is the linear factor. It will be constant for all. For this linear system, the transfer function of the system will be K. If input we are providing S, we are getting V0. So this V0 is nothing but Vs. For the linear circuit, the circuit parameters is not going to change. Means this constant term will be multiplied with every input, whatever we are applying over here. Is it okay? The linear circuit means this linear circuit will multiply the input signal by a constant quantity and will give the output. And for any input, whatever it is, the K is constant. Is it okay for you? Now, according to this is the linearity property. So, according to this property, we have to apply this property over here in this question, and we have to find the, these parameters which are not given. Here Vs is not given. Here V0 is not given. Again, here Vs is not given. So, by the given data, we'll first find out the value of K. For the experiment 1, the V0 equal to KVS, this is the linearity condition. So V0 is given over here, that is 4. The K value we have to find out, okay, fine. And the Vs is 12. So by this equation, K equal to 1 by 3. Is it? Now this K will be fixed for all values. Whatever input we will apply over here, the input will multiply with K only. Now come to this stage, second experiment, experiment 2. Is it okay? Experiment 2 says, again the formula is, now K we already found, and that is 1 by 3 Vs. What is missing over here? Vs is missing. Okay, fine. What is the value of V0? V0 given, that is 16. 1 by 3 Vs. So Vs is nothing but 48 volt. Is it okay for you? Now this third and fourth, this is for you. I hope it's pretty clear for you. See, this is the problem based on the linearity concept. Okay, simple, we apply the linearity concept or linearity formula. Okay, now come to this problem number 6. Find V0 by superposition theorem. Again, where is the V0? Here is the V0. And they are asking to find the value by superposition theorem only. Superposition theorem again says we have to apply the input independent sources one by one. Individually we have to find the V0 across 5 ohm resistor, and then finally we have to take the algebraic summation. Is it okay? Come to the next now, the 7th one. Again he is asking find the I0 by SPT. Where is the I0? Here is the I0. And he is saying that find this by SPT. So see friends, here dependent source is given. So this circuit I'll do for you. Okay. The given circuit is 6 ampere. Here this is 40 ohm. Okay, fine. This one is 10 ohm. Here dependent source is given. And the value of the source is 4 I0. Is it okay? And this is nothing but it's connected over here 20 ohm. And the value of the independent source is given 30 volt. Is it okay? And this dependent source is depend on the value current given over here in this circuit. Okay, and we have to find out this I0 by SPT only. Is it okay? This is the I0, the current and the branch of 10 ohm resistor, and by the SPT only we have to find out the I0 value. By SPT we have to find I0 value. This is our task. Now how many independent sources we are having here over here? We are having only 2 independent sources. Number 1 is 6 ampere current. Number 2 is 30 volt voltage. Now friends, while applying the SPT in this circuit, one by one we'll keep one source and we'll turn off another source. Okay. What about the dependent source given here? Okay, we don't have to touch to dependent source in the circuit while solving any problem by any theorem. Okay, like suppose we'll apply the source transformation or Thevenin theorem or whatever. This is mandatory condition that don't touch the dependent sources. Why? Because the value of dependent source is not fixed. The value is dependent on the circuit parameter. Right? So come here. First, in the first step, I'll keep 6. In the first step, I'll keep 6 ampere. And and turn off 30 volt. Is it okay? How this step will be? This step will be like, I will short it. Is it okay? I have to short it like this. So this source is turned off and this is working in the system. Now see, if I am taking 6 ampere and keeping 30 volt turn off, so here I note, I'll assume this is I note days, because I note is the current given when both sources are acting in the circuit. But if only one of them is acting in the circuit, so I'll keep this I note is nothing but I note days. Okay, now come, what's going on over here? What can I do now? I can apply over here. See, this circuit I'll do by nodal analysis. Is it okay? I'll do this circuit by nodal analysis, or up to this part I can apply the source transformation. I can convert this into voltage and series resistance. I'll do that. 6 is the current, 40 is the resistance, so voltage will be 6240. It means 6 into 4, it's 240 volt with series 40 ohm. Is it okay? See, I just replace the current source by equivalent voltage source. The value of this is nothing but 40 ohm already given, and the value of this is nothing but 240 volt. Is it okay? Now simply I have to apply here the nodal analysis. Okay, this is the V minus 240, this is the 240, divide by, tell me, 40 plus 10, 50. Incoming current minus 4 I naught plus V by 20. 3 branches, 3 branches, 3 branches. So number of terms in equation are 3. This is equal to 0. Is it okay? Now we can take LCM over here 100. So it will be 2V minus 480. Is it okay? Minus 400 I naught plus 5V equal to 0. Is it okay? Finally, 2V, 5V, 7V minus 400 I naught equal to 480. Gives this equation number 1. Now, we are having only one equation and we have two unknowns. So another relation we need to solve this equation, and that will come from here only. See, we have the value of I naught in this 10 ohm resistance. So what is the actually I naught? This I naught is nothing but 240 minus V divided by 50. Is it okay? See, this is the current flowing from 240 to V. So voltage difference is 240 minus V divided by resistance 50. Is it okay? So this is nothing but 50 I naught equal to 240 minus V. We will take this side, so your answer or your equation is 50 I naught. Is it okay? This is equation 2. Now you are having two equations and two unknown. So you can easily find out the values of unknowns or variables, right? So if you will solve these two equations, your I naught, I need only I naught. So the I naught is 8 by 5 or 1.6 ampere. This is nothing but your answer. This is not your answer. This is the answer because of one source only. Because of 6 ampere source only. This is equation I naught dash. This is equation, take A. Now the second part is remain over here, and the second part is we'll keep the 30 volt and turn off the 6 ampere. Okay. So this is your original circuit, 30 volt, and here we are having 40 ohm resistance in parallel with current source 6 ampere. Is it okay? Now our task is, we'll keep 30 volt source and turn off 6 ampere source. Is it okay? So how to do this? Whenever we turn off the current source, we open it from the circuit. Is it okay? So I'll open this. I'll open this current. Nothing is remained now here. Okay. This is the open circuit. Current is 0 over here. Means this part of the circuit is meaningless. What? Meaningless. Is it okay? Now, again here I'll give the name I note double dash. There I give the name I note dash. Okay, because the second source I am taking into consideration. Now your circuit is this one only. Up to this one you have the circuit. Right? Now our task is to calculate this one. So again, what you will do, tell me. Our task is to calculate I naught, right? C. Okay, fine. Now see friends, if you will observe the circuit, from this side, the current coming is I naught double dash. From this side, the current is 4 I naught double dash. So in this, the current will be 5 I naught double dash. Is it okay? So can I apply the KVL over here in this entire loop? A, B, C, D. I'll apply the KVL in loop A, B, C, D, A. I can apply the KVL in any mesh or loop, whatever I want. Okay. So if I'll apply the KVL in this entire this one, I have the value of I naught unknown only. See how? See, the value of I naught is flowing like this in the 10. So I'm starting from the A, I'll come to A. So I'm encountered with negative terminal. So this is 10 I naught double dash. Is it okay? Come to this here. Again the drop is same. Minus 20 into 5 I naught resistance into current. Now come here. Plus 30 I encountered with. Come over here, over here, over here. This is the plus, this is the minus. So minus 40 I naught dash. Is it okay? This is all about the equation. In this equation only I naught is unknown. Okay. So again I'll simplify it. I naught double dash minus 100 I naught dash plus 30 minus 40 I naught double dash equal to 0. Is it okay? Correct. So 10 plus 100 plus 40, this will become 150 I naught double dash equal to 30 actually. The equation will be like this. So I naught equal to 30 by 150. It means 1 by 5 ampere. And the direction of the I naught is nothing but the same. So this is nothing but the I naught double dash. So I total now, this is the I final, I total. I total is nothing but I naught plus I naught double dash. Though we know the direction of the I naught and I naught dash and I naught double dash is the same. Initially we got the value 8 by 5. Here I got the value 1 by 5. So finally this is nothing but 9 by 5 ampere. This is the solution of this circuit by superposition theorem. However, if you will get in the examination, they will not say that find out the answer or I naught in a particular branch with the help of SPT. There it will be completely dependent on you that how you are solving the circuit. Is it okay? So if you will get this circuit in the exam, you will apply nodal analysis directly. Okay, and you will get within 2 or 3 minutes the answer. Is it okay? Come to the 8th one. Use source transformation to reduce the circuit in the figure to a single voltage source in series with a single resistance. See what they are saying. They are saying that reduce the circuit in the form of single voltage source in series with resistance. Single means R equivalent I can say, and this is V equivalent I can say of this circuit. Okay, by source transformation. See friends, this is also homework for you. I'll just give the hint, and I hope this is very easy for you. 3 ampere and 10 ohm, they are connected in parallel, so I can convert into, I can convert into voltage form. Okay, so once we'll get the voltage, again we'll solve these two equations in terms of voltages, and then finally get the values like this. Or we can solve the circuit by keeping 2 points like these 2 points. I'll take 2 points A and B. I can select like this also. I'll open this point, and across this point I can find out the Thevenin equivalent, I can find the R equivalent. That will be nothing but the single source and single resistance. I hope it's clear for you. I'll take the next problem. Okay, come here. Use the source transformation to find out the Vx. Where is the Vx? Here is the Vx. You have to use the source transformation. This circuit I'll solve for you. Okay. Remember friends, they are asking for the Vx. So while applying the source transformation, don't transform this. Don't, please. Because if you will transform it, because this is the voltage source in series with current resistance. So easily we can transform it in the form of current source. But here, for this source we will not do. Why? Because we have to get to know about Vx only. They are asking for the Vx. If you will change it, this Vx will be changed. That's why. Is it okay? So we'll apply the operation over here for these two currents, right? So your final circuit is, I'm drawing over here. This is 8 ohm. Is it okay? This is Vx like this, and this is 40 like this. Is it okay? Now here this 3 and this 10 I can replace by equivalent voltage source. Okay, this is nothing but 10, and the value of this voltage is nothing but V equal to Ri. R is 10, current is 3, so it is 30, and the direction polarity is this side. Because of this only, the current direction will be like this. In the original circuit, the current direction is like this. That's why. Come to this now. This is again current source in parallel resistance. I can again change in the form of voltage. So this will be 20 Vx, V equal to Ri, and this will be nothing but 10. Now my task is to find out the Vx over here. Okay, so can I find out the Vx? See, tell me the current in this circuit. Current in this circuit is nothing but Vx by 8. Why? Because in the 8 ohm, the voltage is given Vx. So can I find the current? Yes, I can find the current. Current is nothing but Vx by 8. And in the series they are connected. They all sources are elements connected in the series. So current will be Vx by 8 in the entire circuit. Now I'll apply KVL from A, B, C, D, A. My circuit path is A, B, C, D, A. Is it okay? I'll start from here. First I'm getting minus Vx, here minus Vx. Then I'm getting plus 30, okay, plus 30. Then here I'm again getting minus 10 Vx by 8. Is it okay? Because here is the Vx is directly given, and I'm writing the Vx voltage equation only. So I'm directly taking it, but here I'm having 10 ohm resistor and I'm having the current in the circuit. So 10 into current is nothing but the voltage. Come here again, minus 10 Vx by 8 plus minus 20 Vx. Okay, fine. Come over here, plus 40 here I'm getting, equal to 0. Okay, so we'll solve this. Minus Vx plus 30 plus 40, this 30 will go out, this 40 will go out, minus 10 by 8 minus 20 by 8. So 20 by 8 is nothing but minus 2.5 Vx. Here minus 20 Vx is given equal to 0. Is it okay? So this is nothing but the total 23.5 Vx, okay, is equal to 70. So Vx is nothing but 70 by 23.5 volt. This is our value, whatever they are asking. Is it okay? Very easy, right? Come to the question 10. Find the Norton equivalent with respect to the point A and B. Is it okay, friend? For the Norton equivalent, I need the Norton equivalent circuit of this is, I need single current source, that is IN, in series with RN. First I will find out the RN over here. For the RN, I need to turn off the all independent sources in the circuit. So this current source will be open and this will be short. Is it okay? So once you will do this, this current is opened, okay? So your 40 and 20, they are connected in series. So this is nothing but 60. This 60 is parallel with 12 ohm. 60 into 12 divided by 72. So this is nothing but 10. RTH is nothing but 10 ohm. Fine. Now come to the IN calculation. Wait a minute. Come to the IN calculation now. The RTH you found 10 ohm, right? Now IN. For the IN you have to short it. This 2 point you have to short it, and this is your short circuit current over here. Now you can apply over here. First change it this by the source transformation. Your circuit will be simplified. This is 120. This is 20. Here the circuit will be like 40, and this is nothing but 80. Here this is 12. The circuit is reduced like this. In this I am having short circuit current. Is it okay? Now this is the 0. This is the 0 also, because this point is directly connected to the ground. So I'll apply nodal analysis over here. So 0 minus, or this plus, here I'm getting minus 120 divided by 20 plus 40, so 60, plus 0 minus 0. There is no meaning of this branch. I told you earlier, whenever the resistance is short circuited, there is no meaning of that resistance in the circuit. It will be dead circuit, right? So I'm here, current in this branch is 0. See, 0 minus 0 divided by 12, it will be 0. And ISC is the outgoing current, so ISC I'm taking equal to 0. So finally, we are having 80 minus 120 divided by 60 is nothing but minus ISC. So ISC is nothing but minus 20, it will be minus 40 divided by 60. This minus will become plus this 6, this is 2 by 3. 2 by 3 is nothing but my current. So my IN is nothing but 2 by 3 ampere. This is nothing but the Norton equivalent circuit, or Norton's equivalent circuit. So friends, this is all about the circuit theorems and problem based on the circuit theorems. In the next video lecture, we will see some more problem and then finish this this chapter. Okay, we'll meet again, friends. Till then, take care and bye.